Hello viewers, welcome back to another section of the Bernoulli's equation tutorials. In this video we have a Bernoulli's equation problem here, and it's an application of projectile motion. Kindly watch this video to the end and don't miss any part of it. Kindly subscribe if this is your first time visiting this channel. So let's go into what we have for this video. Water stands at a depth h in a large open tank whose sides walls are vertical. A hole is made in one of the walls at a depth h below the surface of the water. What is the distance r from the foot of the wall that the emerging stream strike the floor? So let's see, I have a diagram here, and realize that this is a foot tank and I have a hole here. Water is popping out. You know that this water will surely hit the ground. Now, from the top of water to where the hole is h from the question. Then the whole height of the water is what? Capital H. So we have to find the distance r, that is what we call the range with which this water will strike the ground. How do you do this? We apply Bernoulli's principles here. So let's see how we're going to do that. First of all, what you are going to do is you are going to state the Bernoulli's equation, or you just write the Bernoulli's equation down. Then we consider the necessary parameters in it. So let's see. I'm going to have P1 plus half rho V squared, that is V1 squared, plus rho HG, H1G, should give me what? P2 plus half rho V2 squared plus rho H2G. So this is the Bernoulli's equation, and let's see if some of the parameters will be eliminated. Considering these pressures, you realize that this is a vertical what? A vertical container. The pressure at this point, that is the point at the top, and the pressure here is the same, which is the atmospheric pressure, right? So meaning we can get rid of P1 and P2. Their difference is going to give us 0. So we can break this down and you come half rho V1 squared plus rho H1G should give us half rho V2 squared plus rho H2G. At this point, let's consider the speed factor. You realize that in a very big tank, the speed or the velocity of the molecules of the water coming down is almost 0. There is no change in velocity because the water moves very slow. So we assume that there is only one velocity existing. We are not going to have two velocities or two different velocities. So you just take one to be 0. So at this point, I'm going to take only one V, and I'll do away with the other V. So I'm going to have half rho V instead of V1 or V2. Then this should give me my rho H2G. Then I bring this part here, rho H1G. At this point, what do I need? To find our range, we are interested in finding the horizontal velocity, and that is the velocity we need now. So the velocity with which the water is going to come out is what we are interested in. So at this point, I can take rho out because I'll factorize it out. So I'm going to get half V should give me G open brackets H2 minus what? H1, right there. Then, sorry, it's V squared. So my V squared will be 2G H2 minus H1. But let's see something. The change in height, let's assume for ourselves, let's say it's H. So we're going to get V squared is equal to 2G what? H. And our V is simply the square root of what? 2GH. Now we have our velocity. What are we supposed to do? We are supposed to go back to the formula for range, finding range. So this is from projectile motion physics. So it's just a progressive something. We're going to refer the range formula where we're going to have our velocity, our initial velocity times what? our time of flight, the initial velocity times what? The time of flight. So you realize that the time of flight, which is t, is simply given as, so our u is now the square root of what? 2gh. Then our time of flight, which is going to be the square root of 2, then change in height, h minus h over what? G, like this. So once you have this, you are supposed to what? Simplify this expression, and what are you going to be left? So our r will be, once you have this, you can open up a very big square root and you multiply everything here. So I'll have a bigger square root, 2gh, multiplying 2 open bracket h minus h all over what? G. Therefore my g will cancel this g out. Then I'm going to get what? 2 times 2, 4, and 4 will come out of the square root as 2. So my r, which is the range with which the water is going to strike on the ground, is equal to 2 square roots of what? H open bracket capital H minus what? H I have here. So this is how to find this formula. Thanks for watching. Don't forget to subscribe and like, as I'm going to post similar questions this way.